Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We do not use any engines, we do not use any libraries. This is an educational project designed to show the entire set of actual code that it takes to run a game from start to finish. And so whatever it is that you're interested in, we cover it at some point. And if you're interested in being a generalist, which is generally what I am, pun intended, then this is the sort of stuff that you would be expected to know at a minimum, certainly, in order to be a good game development generalist, which is, I think, a pretty good thing to be because, hey, a game development generalist can do just about anything on a project, and you can do an entire project by yourself, which is also pretty handy. So that's all pretty cool as well. But today, we would like to possibly finish up our audio code that we've been working on for a week or two. And I don't even know how long we're working on it. I guess something like six or 7 days. I don't know. So 6-7 hours of audio code. Not very much. But audio is very simple. So we got done most of the stuff that I wanted to get done, and we don't have any particular super advanced effects or anything that we needed to do for this particular project. So, you know, we didn't have to get too much into signal processing or anything like this. So what we'd like to do today is kind of wrap that up, and we more or less finished it yesterday. But I had found that we shouldn't actually do things 8 wide because of the fact that we're doing variable rate. And so what I ended up wanting to do is change it over to be 4 wide. So what I want to do is make that change today, just go through everything, kind of make sure it's all kosher. And then we can pretty much call our audio done and move on to asset pack file stuff, which is something that we would really like to get to because it's kind of holding up, well, honestly, it's holding up pretty much us checking off the asset system permanently from our list. And so we really want to get that done. So let's pop over to the code. And I would mention that if you are someone who has pre-ordered the game, today is day 146 rather, so you want to unzip day 145 source code if you're trying to follow along at home. And you would like your code to match mine at the start. So here we go. Let's take a look at where we left things. I think everything is still in good working order. It's just a little janky internally in terms of how it's structured. Yep, our panning still working, all that good stuff. So no real issues. One thing I did want to mention is since we can't do alignment on reads anymore, because if you remember, I was saying I would like to align on reads. Since we can't align on reads because we support pitch bending, what I wanted to point out is that I had mentioned that we weren't going to bother supporting looping sounds. But since we are not going to bother doing aligned reads, that is not true anymore. So we now can totally support looping sounds. And one of the things that we would want to do to support looping sounds properly, I noticed this the other day, and I mentioned it even, but we just didn't have a chance to get to it, is this code right here. When our samples played advances past the end of the sample count, so it goes over the end, and we say, oh, we may have to play another sound. If we want to support looping sounds, all we have to do is make next ID to play point to ourselves, right? So for example, you know, if I, just to show you what I mean, because we support streaming and looping is really the same thing. Right? Streaming is just saying, oh, when I get to the end of this buffer, I need to play another buffer that's like the next part of this song. Well, looping is just doing the same thing, but pointing at the same chunk over and over, right? So now that we're not going to do alignment, it's pretty trivial for us to support looping sounds if we wanted to. All we would have to do is in here, right, where we do this sort of stuff, right, where we've got our asset stuff, going over all the samples and chaining them together, right? So you can see me doing this next ID to play stuff here, right? Chaining them together. What we could do is if we wanted to, we could take one of our bloops and make our bloops do the same thing. So let's take out the varied bloops that we've got here so that we're only working on one bloop. And what we would do, right, is we'd just say, okay, you know, grab out the bloop when we actually do it, and then set that next ID to play properly, right? So when we come in here, we would say, okay, whatever that slot ID was for the bloop, the thing that comes after the bloop is actually going to be the bloop itself, right? Like so. And then it would just keep on playing and playing and playing, right? And so, you know, right? So again, looping, since we're not going to force the mixer to be aligned, really, really simple. We had already essentially engineered the support for it. We just didn't think of it as that at the time, but because streaming and looping are basically the same, we get it for free. So if people want to add loop sounds, they can. I don't like loop sounds, so I don't think I'll probably use that feature, but it's there, right? And so what I wanted to point out in relation to looping, and I care about it more from the streaming side of things, is that if you look at what's going to happen here, when samples played runs over the sample count, and it's time to go to the next sound, if we don't have to go to the next sound, then it doesn't matter, right? But if we do have to go to a next sound, then setting samples played to 0 is only correct in the case where we actually ended right on a sample boundary, which is going to be the case for one-to-one playback, perhaps, but it would not be the case if we're doing some kind of a pitch bend. And so really what we would rather do here is take samples played and subtract the sample count from it so that it leaves whatever fractional overhang was in there still there, right? Again, not necessarily something you'll ever actually be able to hear as an audio glitch if you don't get just the right circumstances to accentuate it, perhaps. But just worth noting that that's, I believe, a more correct way of looking at the problem, if that makes sense. So that's, just something I wanted to mention. So I think that's mostly all there is to talk about with respect to the looping stuff. I just forgotten to mention it, and we were kind of caught up in stuff yesterday, so I didn't have a chance to. But what I'd like to do here is just go ahead and go through this loop, like I was saying, and sort of pull down the 8-ness of it, and change it over to just working with sample count 4 instead of sample count 8, if that makes sense. Okay, so if we're going at 4s at a time, I'm going to delete that, and I'm going to go through here and take a look at the 8s. So when we do total samples to mix, we're going to switch it down to 4, right, which is good. When we do our loop, again, we're looping over 4s now. And so now we're just going to have D volumes, all of this stuff is going to be based on 4s, not on 8s, right? So now if we take our master volumes here, our master volume is not going to change because that's just a replicated value. But our volume changes actually can be a little bit simpler now. Excuse me. Our volume changes can be a little bit simpler now. There's also something that I would probably want to do to change our naming scheme. So our sample count 4, maybe we should have maybe we should just call this a chunk count, or like a bin count or something, right? I don't know what we want to call it, but we want to call like a chunk of 4 this thing, so that we can stop using the 4 suffix, which I think is possibly bad, right? So maybe I'll actually call that the chunk count, something like that, right? All right, so we'll say how many chunks are there going to be in our thing, and we want to again make sure that the sample count is aligned to that as well, right? So when we come in here, I'm going to change it. So I'm going to call this total chunks to mix, and we're going to call this chunk count, like we did up there. And then we'll say while we have chunks left to mix, we'll keep going. Right? So we go in here to the loaded sound. We have our volume, we have our change in volume over time, and then we have our D volume, which is going to be the volume change for one width, right? So maybe we'd call this D volume chunk, something like that, and D sample chunk, right? Just to unpack that 4, which was getting really pretty confusing, especially when we had master volume 4, which doesn't really make any sense. So I'm just going to call these master volume 0 and master volume 1. Which is a lot nicer because we don't really need to differentiate them any further than that. Then we've got volume here, and volume is actually just going to be, I think we really can just call it regular volume, right? Because the place where we actually used volume, again, later, when we're looking at it here, I think we could always have just used the first element. We could always just do the math in the first element of that SSE. So I don't know that we actually ever need to store volume multiple times, right? Because really we're just doing math that we already did. So I feel like what we want to do here is actually just switch to having volume 0 and volume 1, and that's all I really want there to be, right? And we'd have d volume chunk as well, right? And I think that means we could probably get rid of this stuff in addition, right? Yeah. Well, so we'll take it one step at a time. But again, I think we can kind of clean up a lot of this. So that's really all I want to be doing today, is just, you know, take care of all that stuff so it's not all janky in here. Okay, so if we have d-volume chunk, there we go. And we've got that for left and right channels. Looks like, well, this is actually just d-volume 1, and this is chunk 1, right? So we'll actually see which ones of these we actually need, but let's go ahead and change those there. There we go. And I think that should do it for now, right? So basically we have, you know, we could even look at it in terms of channels, right? So here's channel, right? This is channel 0, and this is channel 1. And that all looks fine. Nothing particularly weird going on there. So I think that's okay for now. So we're going to assert that the samples played is not ever below the 0 count, and that's fine for now. So then we're going to have a new value, which is samples to mix for the chunk. So it's actually going to be chunks to mix, right? And this is going to be total chunks to mix, like so. We're then going to do real samples. So this is just going to be the same thing, but it's going to be chunks, right? Real chunks remaining in sound. We're going to take the sample count. We're going to subtract how many that we have played from that sample count, and then we're going to divide by whatever the delta is per chunk, right? I believe that's correct. Yeah. Is that right? D sample chunk is 4 times sample. Yeah. So that's how much we're going to do. And then in here we've got samples remaining, so this is just going to be chunks remaining in sound. And this is real chunks remaining in sound. And that should be it, right? So this is chunks to mix. And that's chunks to mix. And this is chunks and chunks. So that all looks good. The volume ending check, I guess, doesn't really have anything specific going on here. So this is d-volume chunk, and this is volume chunk count, I guess, right? And then we've got our samples to mix, so that's our chunks to mix. And our volume sample count is just our volume chunk count. Okay. Let's do a little compile here to see where we're at. Sample count 4 is really just chunk count. D volume 8 is D volume chunk. And then we're down. Okay, so that's all good. So in here, and I guess now that I think about it, we have this to-do here, handle stereo. We should probably just do some of these to-dos. We should probably take care of that to-do and this to-do. So after I finish this sweep through, we'll take care of those to-dos as well. So we can handle, that way we can handle stereo sounds. Not that we can actually use them yet, because we don't have them in the actual asset system. I mean, they're supported by the asset system, but not by the wave loader is basically what I would say. So anyway, we're doing the handle stereo thing. That's all well and good. What we would like to do here is make sure all of this stuff works properly. Now what we can do is our sample value now gets a lot easier, right? Because now that we're doing this in chunks to mix, we don't have all of that annoying stuff where we had to do everything twice, which is nice, right? So now we can have just our 0 and 1 mean our two channels types, which is really what we would like, right? So that's all good. So here we go. Let's load those guys in. Again, we can get rid of half of it nicely. And you can see going ahead and doing these guys here, right? We've got our volume 0 and our volume 1 and our sample values. So that's just a lot nicer to read, right? So that's just our multiply accumulate happening there. And that's all good. So let's see. We've got our stores, and those are all good as well, but we only have to do half of them now. We can update these guys just singly because we're only writing out 4 pairs now. And when we update these guys, we can just think of them as 0 and 1. So that's all good as well. So these are d-volume chunk, and I think that's all good. So yeah, let's take a look, d-sample chunk as well there. Let's take a look at where that's at. Right, these guys have to be kind of calmed down a little bit there. D-volume 8 is d-volume chunk. And now we're down here. So now we're just doing, this is just renaming basically, chunks to mix. We've got total chunks to mix, and yeah, I think that's basically it. Not a lot more to it. So let's see where we're at. Uh-oh. That's no good. What did we do? What heinous crime have we committed, ladies and gentlemen, in our fussing with the sound code? So let's see where we're at here. Total chunks to mix is 96. Chunks to mix, chunks remaining in sound are 0. So the sound is over, right? Chunks remaining in sound is 0. So we won't mix anything. Did we mess up our end condition potentially? We may have. Yeah. Yeah, so this is kind of a little bit janky here, right? When we computed our ending, this is not gonna do it anymore now that we're not. We kind of wrote that back when we were doing non-floating point playback, right? So we're going to have to be a little bit more careful about that to be sure. So let's go ahead and mark that guy in here, clean up a few more things, and then we'll go through and do our 3 to-dos. This is not an acceptable check for the end, right? Okay. So now I just want to simplify this guy a little bit. I just want to go through here and see what we can do in terms of simplifying things potentially a little bit. So it looks like we can just make that in there. There we go. Yeah. So I'm just going to take a quick spin through here and see if maybe some of these things don't have to be duplicated anymore so that there aren't so many different things sort of flapping around, if that makes sense. So let's see. Yeah. The first thing I would observe is that if you look here, we're storing volume here, and then we're storing it again here. And we really don't need to do that, right? We don't need to keep incrementing to that guy. So these are really temporary values to some degree that should probably only be used to set up these things here, right? At least that's what I would suspect. And so if we take a look down here, like where we're actually updating these guys, we should be able to not do that anymore, right? Like this should be able to go away for starters. And then here where we're actually using that volume, right? what we could do there instead is the current volume that we want to write back, we could just write out the individual, we could just grab out the one that we want, right? So we could just go ahead and grab out the actual individual values from the SIMD, like so, right? Yeah, so what do we call those? Volume 0 and volume 1? Yeah. So that would get us out of the business of updating that variable, which seems good to me, right? Of course, I gotta actually address it properly. So yeah, I think that's probably what we would want to do there. And looking at that, I mean, it's probably nice to still do it to do dvolume this way though, and volume, just because it makes it easier to initialize these guys just by having them. So we'll leave those temporary calculations. I just wanted to get them out of the actual loop so that they're not being used anymore. That seems like a good idea to me anyway. And because they're used up here in the startup or whatever. So I just want to take it out of the loop. That all seems pretty good. Yeah, I don't see anything else immediately obvious that I would want to get rid of. I suppose the other thing we could do is actually just store the volume as SIMDs, but that seems overkill. So let's see here. We have not done we're still on our sort of our simpler path, right? Where we do just the basic loads of 4. And so if we wanted to do something a little fancier here, like supporting the lerp, which I guess we decided we couldn't really hear it. So I don't know if we want to bother supporting the lerp, but maybe we should just write the code in there just cause. So if you want to do the lerp implemented the way we did it here, where we've got a lerp from sample 0 to sample 1, right? We would want to do something where we loaded sample value 0, and that's again going to be sort of a truncation here, right? So this is going to be a floor. And we probably want to save those things, so we'd have to do this sort of a thing, right? We'd have to do a sample index where we would actually, I guess we could do it this way, right? Oops, that's no good. Where we would actually go ahead and grab these guys out, right? So we do, this sort of thing. Oops. So that way we actually know what they are, so we can do the frac and all that stuff, right? So if we have these guys, we would also need to do, I guess, well, the frac is going to be, yeah, so we would also need to do like sample pose, right? We'd want to do that as well, right? So we do like sample pose 0 equals sample position, and then we would do our sample index is going to be that sample pose rounded down, and then our frac, right, is going to be whatever that sample position is. Oops, whatever that sample position is. Minus the floor value, right? So again, just duplicating this code right here. So we have to do this for all 4 of the samples, right? Because we're going to have a different frac for each of them as well. Now what we could do is we could widen that as well, which I guess maybe we would like to do, right? So you could imagine me doing something like this. I'd say, okay, I've got, well, I guess I've got one of these, right? And I do sample pose, and that's going to be equal to mm set RPS, and I want to set it to like sample position, sample position, sample position. I want to basically set it to be the various sample positions. I'll just put them into a wide thing themselves, right? Something like this. So now I've got the sample positions wide, and I've got the first sample, second sample, third sample, fourth sample, right? And then I can just I could floor them all together, right? Or in this case, I guess truncate them all together, right? So we got sample Index is going to be convert p. It's like CVTT PS. What is it called? Is that? I think that's what it is. Forgot we moved it over to optimized. Yeah, so you can see here, you know, when we're doing our linear blend here, where we want to get the fractional values and stuff, you can see this is the truncation, right, that we were doing. So we want to do exactly the same thing here, right? We just want to truncate these values so that we're taking them and figuring out what their closest actual index is, right? And then I'm going to do, again, exactly the same thing we do here, right? It's literally the same exact thing for a linear blend, whether you're doing it in graphics or doing it in sound. What we want to do is figure out what the fractional value is, and the fractional value, again, is just going to be subtracting that sample index from the original sample pose that we had, so that we can see like how much they were off, right? So that kind of nice, because that means we can do that whole thing sort of together, right? And that gets us out of the business of having to do any of this other ridiculousness, right? Now, unfortunately, the thing that does not get us out of the business of doing is doing the loads. So we have to actually do the loads again, which is really too bad. But there's really not much we can do if we want to support the arbitrary pitch bend. I'm not sure there's really much of a way around it. So when we come in here and we want to get sample value, I guess, I'm not sure what we want to call it. Sample value, the one we're going from and the one we're going to. So maybe we'll call them floor and ceiling, like sample value F and sample value C. So when we load these guys in here, we need to get them out of the sample index, right? But the sample index is not something you can actually address directly, right? That's a thing that's an integer now, right? It's an M128i. So what we would need to do there is, again, do exactly the same sort of tricky thing we did before, where we're sort of addressing into it and saying, oh, I want to get, you remember I just did it down here, right, where I saying I want to be able to get something out of the SIMD value. So I'm just going to go ahead and say, all right, give me that value, give me the value of this guy as if he were an int32, and then we'll grab the 0 with 1, right? So let's do that. And that should do it, I think. We're grabbing those guys. And then what we have to do, since that's our sample index, we have to also grab whatever the thing is on the other side of it, right? So the ceilinged value. So we would need to do, one over that number, right, to fetch into the next one. And so that's really it for that. I think that gets our floor and our ceiling values loaded in properly. And then we just need to actually take some action. So this stuff is now all represented in SIMD, so we don't need that, and we don't need that anymore. All we need to do now is just this part right here where we do the actual lerp. And of course, lerping is pretty simple, as we know. A lerp is just is just an add of two things that have been multiplied by the lerping coefficient, right? So we want to take that sample value floor, and we want to take that sample value ceiling, right? And what we want to do now is we want to multiply these by whatever the appropriate fractional values are, right? So the fractional value, we multiply directly times the ceiling to move toward it, right? As the fraction goes up, we blend in more of C. And what we want to do is have inverse of the fractional value to multiply by F. And so you remember how to do that, right? We just subtract it from 1, right, to get it to be an inverted value. And that performs the lerp. So all we really need now is that constant. We need a 1. We don't have a 1 right now, right? We had a 0. I guess I will stick these up here as little constants just in case anyone wants them. So we have a 1 and a 0 now. And so now we can do that lerp. So let's see if this compiles. It does. Of course, that doesn't mean it works. Quick check, just make sure everything makes some sense. We've got the sample pose here. And we're just setting that to be sequential samples, moving by D-sample, which of course may mean we're not moving a whole sample index at a time. It's just sequentially where we're sampling from. It could be more than one sample at a time, could be anything really. We then grab our sample index out of it by essentially truncating the value, which is a floor in this case, because we know we're positive numbers. We then take the fractional value to figure out how far we are by taking the number that we just floored, converting it back to real, and subtracting it from the original sample pose to get just the fractional portion. We then go ahead and grab out those samples, right? We grab out the actual sample locations and then their neighbor to their right. And then we do the lerp, right? We multiply the floored sample value by the inverse of the fraction and the sample value that was ceiling by the fraction to do that standard blend equation. Everyone should be super comfortable with that by now because we've done it so many times. All right. And let's just double check by setting some kind of a really weird sample rate on this particular sound here, just to make sure that we get something weird. So it all sounds pretty good. We just got that nasty little bug we also have to take care of. So that all seems fine, but we have obviously some to-dos that we might want to take care of here, so let's think about our to-dos. So the first one is this nasty bug with our termination condition is way too sloppy, and that's not acceptable. We're going to hang in here all the time if we leave it like that, so that's no good. So what we want to do here, first of all, I think, before we actually clean it up the calculation, is we want to do the same thing we did with volume ended. Which is that we want to set, instead, we want to set sound finished here. We essentially want something that says like, you know, input ended or something like that. And then we'll use input ended, like input samples ended, right? So that we can know that we either did or did not expect ourselves to end. And the reason I'm doing that is because there's a bunch of kind of finicky math in here. And while we do want to go through and make sure that we get it as correct as we can, what we don't want to do is have our program hang if we made a mistake somewhere. Because it's very easy to have a mistake in there that's hard to find, that we don't see, but that some poor player finds because they did something we didn't test or whatever, and happens to get in exactly the right conditions. So what we'd rather do is say that up here, right, just like we did with the volume, we want to be able to say that the input samples ended like this, right? So that we say, okay, when we do our chunks to mix, we're going to expect it to do the total chunks that are in the buffer. If we have to stop early because we don't think we'll have enough samples in our input buffer, well, that's fine, but remember that so that we will actually exit appropriately when we get down here, instead of checking some things that we just hope will line up based on the math that we did, but we have no idea if they actually will, right? Or we have no hard guarantee that they actually will, right? And so that's I think better there, right? And I just had this in a case that was crashing. We'll try that case again. Not really a comprehensive way to do it, but just to make sure. Excuse me. So that, okay, and that's actually kind of interesting. Whoa. That's not what I would have expected at all. So I was going to say, I could expect that to be slightly off because of this thing here. But yes, is that getting triggered? Am I triggering that in a dumb way? I'm going to actually put that assertion a little further down because I want to kind of take a look here. I want to do this. Right? Because I was going to say we could have an off by 1 there, certainly, because of what we just witnessed for input sample played. And so we do want to fix that, but that was a very large number. So I would like to know why we were getting that. Okay. So I'm just putting the assert, I put the assert in a place where I'd be able to inspect the things I actually wanted to inspect, if that makes sense. So let's see. Loaded sound has a sample count of 480,000. Really? Okay. I'm not sure I believe you. That sounds like an unusually round number. Oh, you know what? But that's fine, because this is probably one of the music chunks, and we did set those to be 10 seconds apiece, I believe. So that's what it should have been. That's fine. And so let's take a look at playing sound. See what that is. And samples played, wow, that is just not even close, right? That is not even remotely close. So that could just be because our math is sloppy, right? But I would like to see what the actual situation is here before we conclude that, if you would. So let's see. Real chunks remaining in sound is 312, 8, 9, 4, 7, 4, 5. So we round that down to 313, right? I guess that rounded up, sorry, to 313. And the chunks to mix, 120, chunks remaining in sound, 313. So the chunks to mix was something, I guess we don't really have a way of seeing what it was beforehand, if that makes sense. Has total chunks to mix been updated at this point? It has, unfortunately. But that's okay, we can reconstruct it. So chunks to mix and total chunks to mix. So total chunks to mix plus chunks to mix, right? 360 was the actual number there. So that's how many we had to go. And what we said was, well, we think we've only got 313, so it makes sense that we would have to stop early, right? Now, what's weird is why we thought we had to stop that early, but I could be just missing something obvious here. So D-sample chunk is just exactly what you would think it would be. The samples played and the sample count. So yeah, when we look at that number, I mean, I guess what I'm saying is there's definitely a serious bug in here, I think, because there should be no way for it to be that far off of where it would actually need to be, right? Yeah, I'm gonna take a look at this guy. So chunks to mix is 480. Total chunks to mix is also 480, as we would expect. Remaining chunks in sound here is 63,157. That's how many chunks are left in the sound, according to this. So let's see if that actually makes some sense, if that's a reasonable thing to think about. So we've got 480,000 is how many samples there are, right? And presumably there's been none played yet, right? Because I stepped right at the beginning. So none have been played. So if we want to know how many of these there are going to be, we want to be able to see whatever, D-sample chunk tells us is going to be the number of chunks in here. So let's see how many that's going to be, right? Let me see here. If we said D-sample chunk, so divide D-sample chunk, how many of these are there? That's 63,157.8. Okay, so that's the value that we're actually seeing. So if we were going to see how many of these chunks we were going to do, if this is the number of chunks we were going to do, how many samples would we actually consume at that rate? Like, where would playing sample actually be? So we'd want to multiply it out by D-sample chunk again. And hey, not surprisingly, we get the exact right answer. So that all seems pretty good. I guess the question now is what happens once we do some rounding in here. So chunks remaining in sound, right? How many chunks did it think were remaining in sound? 63,158. Yeah. Yeah. All right, well, let's go ahead and jump right to the bad case, and we'll see where we're at. All right. So here we are at the bad case. We are asked to do 480 chunks. We believe there to be 313 chunks left that we could actually do. And so is that, again, a reasonable value to think about? So our loaded, we know our loaded one has 480,000. Our playing sound is at 47,762,1,781, right? So let's take a look for this. Where are we at? So we believe we have somewhere around that many samples left to play. And so let's take a look at what the actual, if we take a look at that actual value, 2378, 2189999, right? Times D sample, divided by D sample chunk, right? What is happening? All right, some kind of heinous nastiness happened with the cut and pasting there. We won't ask. We'll just assume that Visual Studio is doing something fantastic. So that's how many we think we're going to have. And so as we increment that, if we go ahead and take that actual number, 92355654509 or whatever, and multiply it by D sample chunk, we get exactly the right value, so that's good. If we are to multiply it by what we rounded up to, again, super duper close. So yeah, that seems like everything was done properly. So what's our problem here? We're not doing any volume lerping. We start out at samples played, which is this, which is what we think it should be, right? And then we're going to add as we go. So you know what, honestly, I wonder if this might just be a case of the accumulator. If you remember, I said this very early on. I said the accumulators may not actually have enough precision, and we might have to do them as things that divide themselves out rather than actually doing an accumulation every time, because the error as it accumulates can get up to the point where it's actually significant. So I don't know. We'll see. So what we expect the sample position to actually be, right? We would expect the sample position after we're done to be something like 477,621,781 plus 23788, right? So that's what we would expect to see. And sample position is going to get chunks to mix, going to be done 313 times, right? It's going to be done this. Desample chunk is what's going to add, and I'm just betting that that's all that's happening here, right? So when we come down here, let's see what sample position actually is. Here we go. Sample position. So yeah, really not. It's not close enough. I mean, it's bad enough that I think we should probably be concerned about it. Although that is not nearly as bad as what we were observing before. So what actually happened in the case we were looking at? I wonder if I just sort of mislooked at something, because it seems like what I was seeing was way worse than that, right? Yeah. Anyway, so let's see here. So loaded sound, we've got playing sound, loaded sound, samples played was this. So yeah, I feel like playing sound, samples played, you can ignore that. You can ignore that. Disassembly, set next statement, go to source code. So what I want to do is just see what that ends up being. Yeah, so that's more what I would have expected, but that's not what I remember seeing last time. I remember it being way off. Now maybe we just hit a different case. But that is exactly what I was worried about when I was saying before about that problem where you're going to have this nasty situation of the accumulator is not going to be precise enough. And that definitely does look like a problem, right? So I'm not sure exactly what we should do about that. I'll have to think about it. What we can do is we can make this, since the sample position is actually relatively important to us, what we could do is we could spend the money. We could spend the money on making sample position actually be accurate. That's not particularly hard to do. Right? We could totally do that. Whether we want to do that, I don't know. But if we did want to do it, I can show you how we would do that. And then I guess I would just have to think about whether it's what we want to do. So here's how you would spend the money to do that. So when we come through here, we end up with this, this D sample chunk, which is basically saying how much we want to move over time, right? And for something like volume, that's totally fine because we don't care if we're a little bit off when we get to the end. No one's going to be able to tell. But with the sample position, since we care about things like where buffers end and all that sort of stuff, we may want to be more careful about that. And so what we want to do here is basically change up to saying that we, instead of a sample position that's accumulated over time and where the floating point error can build up, what we want to do is say we have a begin sample position and then we have an end sample position, right? And our begin sample position is just going to be equal to samples played, right? And our end sample position is just going to be whatever our begin sample position was, and we would like it to come out to be whatever the actual ending was that we had in mind up here, right? In fact, what we could do is move this up here and actually do this calculation exactly perfect as well, right? So we could say, well, the begin sample position should be, samples played. The end sample position should be whatever the begin sample position was, plus, the chunks to mix times the D sample chunk, right? Like so on. In fact, that's probably fine. I think we can only be off by a little bit, so never mind. We don't have to do it. We don't have to do it that exact. We can just do it like this down here. So the chunks to mix, we multiply by the D sample chunk. That will give us the beginning and the end, right? And then instead of sample position being an accumulator, what we would do here is we would just get rid of that concept altogether. We would get rid of the accumulator. We would say that this was going to be end sample position, right? So we just hop right to it there. And then sample position would just be something that we back compute as we step, right? So the way that we would do that is we'd say, well, we know that loop index goes from 0 to chunks to mix, right? So what we want to do is have some way of quickly recovering what the samples played should be. What the sample should be based on that loop index, right? So we want to take the loop index, and we basically want to multiply it by a coefficient, right? Which is, 1 over chunks to mix, basically, right? If that makes sense. So that as it moves towards chunks to mix, we actually get closer and closer to 1. We get closer and closer to whatever the value is that we wanted, right? In fact, we don't really want image, so that would move it from 0 to 1, and we still have to multiply. We still have to blend between these two guys. So what we can actually do is, I guess we can do that a little bit more straightforward. What we can do is this, right? Plus loop index C, which is just whatever we would have to multiply loop index by to move it to end sample position, right? And so what's that going to be, right? Well, we know that we're going to have it range from 0 to chunks to mix minus 1. Like the final one is going to be chunks to mix minus 1, right? And this end sample position, of course, we don't want to actually end there. That's like one past where we want to end, right? Because the chunks to mix, that's how many we will be at after we do the last one, not before. So I believe that loop index coefficient is just going to be whatever the end sample position is minus the beginning sample position. So however far we have to go, divided by whatever the chunks to mix is, right? And that way we can just take loop index and with a multiply and an add here, we can just go ahead and reconstruct sample position entirely, and we don't have to accumulate it, right? I think that's a little bit more correct. Let's take a look. So let's see. Here is our bad case again. Let's see how we do this time. So we come through here, and we're going to end. Let's see, input sample, oops. That's not what I meant to do. Input sample ended, so we come in here. And let's see, our samples played. That's perfect. Right where we thought it should be. That's great. Yeah. All right. So hopefully that makes some sense what I did there. And I'm going to explain it just kind of really simply on the Blackboard for a second, just so people understand, because it's a pretty useful thing for people to know. So let me just go ahead and say it pretty straightforward here. So accumulation versus, I guess I should say accumulation versus explicit. I don't know what you want to call the other kind, now I think about it. So if you have something like we had, where we need to know the sample position, and that operation, right? There's two ways that we could phrase it. So we have some value, right? We have we have some loop index. I guess we'll just call it I. And for any given I, we're coming out with some value, right? In this case, it's the sample position, right? So in this case, we've got our f of I is going to be the sample position. Now, if you can just, there's different ways that we could choose to compute this, right? One way that we could choose to compute it is by picking whatever the first thing is, so whatever f of 0 is, right? And then adding I times the times whatever the delta is, right? Whatever the delta is from one to the next, right? So we can always say, okay, we can start at the first value, and we can recover any one of these values, right? By just multiplying whichever one we're on by however much the change is per step, right? That's one way to do it. Another way to do it, right, is saying that, well, whatever the f of I is, it's just recursive, right? So f of 0 is going to equal something, and f of I is just going to equal, inductive, I guess is what this would be called. Like those inductive proofs? That might be a reasonable name for it. It's just going to be whatever the previous one was, right, plus the delta. Does that make sense? And so we were using this method here. We were basically saying, okay, we're going to start f of 0 at some value, right? Whatever it is, right? The samples played. And then anytime we need an fi, we're just going to assume that we kept whatever the previous one is, and we're going to add in whatever the delta is. So we would have loops, we have our for loop here, right? And what we would do is we would say something like, oh, at the top, we would just say, whatever our value is equals something, and then in here we would say our value equals whatever the delta is, right? So that would correspond to this kind of a construction, right? This is how we would do it. And the problem with that is every time you do an addition like that, you can have a rounding error, right? Because floating point only has a certain amount of precision, and so when you're dealing with numbers like we were with like 1.9f was like the step size or whatever there, when you're dealing with fractional stuff like that, you get rounding error every time you do that. And we know that these numbers are like 400, right, or something like this, right? So we have 400 rounding errors building themselves up as we do this, right? Rounding error, rounding error, rounding error, rounding error, rounding error, rounding error. So you do an operation like this once, you don't necessarily care that it's got rounding error. You do an operation like this 800 times, and each one depends on the previous one. You compound the rounding error, rounding error, rounding error, rounding error. And hey, when you get to the end, it's not where you expect it to be by quite a bit. On the other hand, if we were to do it like this, then we only have rounding error in a couple places. We only have rounding error on this add, this multiply, and the original storage amount of these values, which, by the way, we had here as well, right? So we had rounding error just in computing the values to begin with. That didn't change between the two. And so this one just has, 2 rounding errors in it, and this one has the loop count number of rounding errors in it. And so, sometimes you care. And in this particular case, we care, I think. As you can see from it actually happening in practice. So in this case, it's pretty free for us to do the calculations this way. And so since we are doing that, since we have found that's a reasonable thing to be concerned about, it seems like maybe the things that are done that way should just be all back computed, right? Because we could do the same thing here, right? For our volumes, instead of having them be accumulators, which would also be highly erroneous potentially, what we could do is make them into the M128s for volume 0 and volume 1 here that are just computed this exact same way. So they're MMAD PSs of whatever the begin volumes are, and then we just multiply D volume chunk, right, MMMul PS, by, again, whatever this sort of a value based on the loop index, basically, right? So, oh, we're at the Q&A. Well, you know what? Then I won't do that. I will do it tomorrow if we're at the Q&A. You know exactly what I'm about to do. So anyone who wants to do that tonight for homework can go ahead and do that. But it is time for the Q&A now. So let's go ahead and do that. And then what I'd also like to do, so I'll move that up there. So I guess to do Casey, move volume up here to explicit. And the other thing we would want to do there is make sure that we are always, well, actually, I think that's all good. Yeah, I think that's all good. What we could do is we could just be absolutely sure here. We could say if playing sound samples played is less than 0, samples played equals 0. Just to add a little bit extra, potentially unnecessary security. All right. All right, does anyone have any questions on that? Please prefix the questions with Q:, so that I will see them. You folks know the drill. Garlinda Bloom says, you're a rad dude. Technically, no, not anymore. I don't work for Rad anymore. I used to work for Rad, and so that would have made me a rad dude. But nowadays, I'm a normal dude. What would you recommend as a good tutorial source or area to learn how to code? Well, to be honest, I don't know. It's on my list of things to do someday to make a good tutorial series for brand new people, which is, Handmade Hero is kind of for people who sort of know how to program. And so, the day one of Handmade Hero is still fairly assumes, some familiarity with programming. There is a 5-part Intro to C series that I did as a test stream before Handmade Hero. But it's, it's only 5 days, so it doesn't really cover everything that would actually need to be covered. So, someday there's probably a good 100-day series or something to do, which is just like introduction to programming for people who've never done it before. But I don't know what's good in lieu of that. Robot Chocolate Dino. Is your SIMD clear to 0 faster than memset? So I would assume, just thinking off the top of my head, I would assume that they would both be the same speed. But I don't know. That's my assumption. And the reason that I say that is just because the majority of the time of that clear is going to be just streaming out the memory. So I would assume that no matter how you did it, it would be fine. We might be a little faster. We could maybe a little bit faster because we know that the things are aligned. And memset might have to test first to say that they were aligned. But you know, I mean, if you want to look, if you want to get some perspective on what it's doing in there, you can certainly try and see what ends up happening. So you know, if I was to come in here and actually do the same stuff, right? So if I wanted to memset, you know, dest 0 with chunk count times size of mm128, like so. And I think that's the format for memset. I don't quite remember. But if we, you know, if we did something like that, let's see here. Sorry, I gotta move those aside. So if we did something like that, you should be able, well, I gotta actually have memset better. What is it, memory.h? Yeah, there we go. So, you know, we can take a look at these guys just to get a feel for what is actually happening. And so if we take a look in here, you can see what's going on, right? We're just doing move APSs in a loop, like so, right? And I'll be honest, I don't really understand why it looks like that, but so you can see this is the instruction stream, right? For that's happening, right? So you can watch it go. So to get some idea of what's involved, that's what's involved, I think, for the most part, right? And we can grab this out, put it into the scratch buffer. That's what's actually right getting executed, and we can, yeah. So you can see exactly what it's doing too, right? It's incrementing the values, and then storing them out. So you can see here it's taking RCX and storing it in a temporary, right? RCX is the pointer, the dest 0 pointer. It's then incrementing the dest 0 pointer and then using the old value that it kept as the temporary to do the store. Then it goes ahead and again gets a temporary for RBX and does the exact same thing. Now, you know, I'm not really an x64 guy. If Fabian were here, I would ask him why it's doing it that way, because it feels like you just rearrange these and just do XMM word pointer RCX, right? And then add to RCX afterwards so that you could get rid of this mauve. But I suspect, assuming, I mean, the compiler might just be dumb, right? And that may have just been a stupid thing to do. But assuming that that's a smart thing to do, it may be that there's a good reason why you don't want to do that, because you want to like overload, you know, you want this add to be overlapped with the move APS, and so you want both values live or something. I don't know. So anyway, but that's the entirety of the code for our memset. So now what we can do is look at the code for the memset in the C library, which is here. And so here we go into that, and you know we're going there. So yeah, I mean, just looking at this, I guess I would say I think we probably should be either the same speed or faster, because their loop is not doing aligned and it's not doing wide. So, you know, are we going to be faster? Because it's probably just bound by memory anyway. Are we going to be faster? I don't know. But I don't think we could be slower, right? Because, I mean, look at this. That's just, you know, that's definitely doing things less efficiently than we were doing them, if that makes sense. So, and just to give you a comparison there, again, I don't necessarily know the nature of your question. I'm just trying to give you some perspective on how you could investigate things like this. So, you know, looking at this, so you look at how this is working. It's doing some kind of nastiness here where I guess it decided that it could write out several of these at a time, right? You can see it doing writing out to RCX, then RCX plus 8, then RCX plus 16. So it's writing out like, you know, three 8-byte values at a time. And then it's moving forward and writing backward, you know, it's writing the, you know, negative 28, negative 20, negative 18, negative 10, negative 8. So it's writing up, right? And so they're writing 8s at a time, and we're writing 16s, and they really don't have much less business. Now, what they do is they do a little bit wider. So, you know, they have less iterations of the loop to do, because they're doing, we're writing 16s at a time. They're writing 1, 2, 3, 4. So they're writing 4 different 16s at a time. So they might get more of a win for having less business to do with increments, because they've reduced the number of increments, right? So there's that as well. So, you know, that's I guess what I'd say, is, you know, now you have some perspective on who's doing what. If you really want to know which one's faster, though, same answer as always. You got to time it, and you got to time it in real world scenarios. So you would have to actually go in here and, you know, have something that actually did an if zero around these two guys, you know, that did this sort of thing. Actually get it in a big enough thing to matter, and then actually time it. But yes, so hopefully that gives you some perspective, though. And you saw how I did that, right? So if you want to just get an idea of who's doing what, you can just step into the disassembly in an optimized build. You notice I switched it to optimized first, because otherwise the compiler, who knows what the compiler's going to do. But that would, you know, gives you just a little bit perspective what's going on. If you actually then want to get down to the bottom of it, of who's really going to be faster, again, you're going to have to time it. But now at least you know who does what. Do you have a public style guide? I guess I don't know what a public style guide is. No? I guess would be the answer. I'm looking to learn something other than Java so I can have diverse knowledge. Any recommendations on how to go about doing that? Well, I guess my recommendation would depend on what it was that you were trying to diversify towards. So, like Handmade Hero, for example, what we do here would be really good for you if you were trying to diversify into like more low-level programming and knowing exactly what the computer actually does with the code that you write, and how you manage memory, and how you do a bunch of things like that. Because Java is usually about abstract, you know, being very abstract in those ways. You know, you're on a virtual machine, you have all these other things. You don't really connect with the CPU and stuff like that. So, you know, that's a good thing. But, you know, that may not be what you're trying to diversify into. If what you're trying to diversify into is like, I want to try writing in a pure functional language or something, right? I want to know what that's like, or, right? There's a lot of different avenues you could explore. I want to know what a declarative language, I want to go program Prolog for a while, because, right, that'd really mess with your head. So I think the answer there really has to be about what do you actually want your diversity to be about. And if it really is just a little bit of everything, then I would say, yeah, you'd probably want to do all sorts of stuff. Do a little tiny project in ML. Do a little bit, you know, watch a little Handmade Hero, do a little of this, do a little of that, right? Go follow the instructions for making your own operating system on Raspberry Pi. You know, do a whole bunch of different small things if all you want is just general diversity. But if you have a particular avenue that you're looking at when you're like, I want to diversify more in this direction, then I would say think about what that is and what kinds of projects you could do that would be most directly speaking to that. At what point did you first feel like you could easily write software independently? I would say that I probably, when I was 16, and then I lost it again when I was 18 because I started doing object-oriented programming, which is awful. And then I gained it back again probably around 21, 22, when I switched back to not object-oriented programming. Why is the sample index floating point? Is it for the pitch shifting? Yeah, it is for the pitch shifting. It's so that we can have the samples play back at an arbitrary rate. Why do gaming companies like Riot or Blizzard Entertainment use C++ over all the rest? Would the others not work? So, I mean, honestly, the answer there usually has to do with control. I would say the way to look at C and C++ and why they are prevalent in the game industry is usually about risk management and control. If you write, think about the scale at which these people are operating, okay? You take a game like League of Legends, because you mentioned Riot. There are many billions of dollars a year riding on that game for Riot Entertainment, right? I mean, it is economically a massive, massive product. Now, if you program in C or C++, then you know one very basic thing, and that is that you pretty much will never have any unexpected thing that you did not create cause your game to slip or crash or not run on a bunch of people's machines or whatever, right? You know that that can't happen with your piece of code. Now it can still happen with the graphics driver. And don't get me started on that. But what you know with C and C++ is you compile directly to a binary and everything that's happening in the game you wrote. Now, if on the other hand, you were to write it in, say, Python, you now have no idea, right? You could get to some part of your development process and all of a sudden, something about Python's internals starts rearing its ugly head, and now all of a sudden, you have absolutely no ability to actually do whatever it is that you need to ship your game, because something in the core of Python that you were using is busted, right? And now your team suddenly has to shift from being an expert in League of Legends, which is what they were supposed to be programming, and you have to switch over to being an expert on Python and write your own Python interpreter, or take the open source one and change it, or do all the other sorts of things, right? And so I suspect that since games have always been about important, hard performance things, 30 frames per second, 60 frames per second, maximizing, the impact that the technology has on the player's experience, all these sorts of things that other domains don't tend to care about very much and don't have central to their being. I would say that because of that, they sort of probably, I think that the industry grew up with a very deep and I think probably well-founded mistrust of these technologies that are meant to save programmer time by saying, well, we don't really know what happens in there. Some memory, it gets used, and there are some interpreters, and they do some stuff, right? And so the C and C++ part is about that connection between knowing that what you write controls directly what the CPU does, and you have a very easy path of reasoning about what it will cost to do every individual thing, and there are no surprises. So you can't get to a point and then suddenly something you do that's very simple completely changes the performance dynamics of your game. That doesn't happen, right? Whereas in pretty much all the other prevalent languages, Java, C#, Python, it's not true. Because there's a virtual there's a virtual machine underneath you, there's a garbage collector underneath you, there's like all kinds of built-in types that God knows what they do, blah, 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 right? And so really, I think that is what underlies the mindset. I think that game developers would like higher level language stuff, but I think they would like to have it in a way that doesn't pose those risks, which are real. And if you don't believe me, you can go read like the Minecraft maintainers talking about how there's huge hiccups in the performance because of the Java garbage collector running and what they tried to do to work around it and blah, 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 right? And all this sorts of stuff. So, I think that's the thing. And if your project never happens to hit those things, then, that's okay. And so if you're a tiny developer and you're just making a game and you're like, I want to use C#, and, you go use it. And even if maybe you do encounter some problems, maybe that's not the end of the world, right? But your Riot and $2 billion or something is riding on you guys not hitting these snags that cause serious problems or not doing whatever, and you don't want that risk. And I think they just, the people who work on this stuff just don't want to accept that. They don't want to accept that level of uncertainty and that loss of control. And that's also why you'll see some very paradoxical things happen in the game industry, like people will write their own scripting language or something that has all these same drawbacks, but from their perspective, that's okay because they made those decisions and they are an expert in that scripting language implementation because they wrote it. And so they're not afraid of hitting some mysterious problem in someone else's technology that was unforeseen, right? You might think of it almost like a Titanic iceberg thing. If you like, there's plenty of icebergs, right, in C#. And there's plenty of icebergs in Java, performance icebergs. If you are some little dinghy with a little outboard motor and you're like just tooling around out there, you probably don't care if you hit the iceberg. Like your little guy will get kind of stuck on there and you'll just like push it off and then you'll like go away, right? If you're the Titanic, you can't afford to hit that iceberg. Like it's really costly. And so I think that's just the case with, AAA development where you're like, if we are doing this massive scale development and we have all of these risks already that are separate things and all this other stuff, we are not willing to take on a language that we know has these dangers in it because we can't prove to ourselves ahead of time that we won't hit them. And we don't want to take on the burden of managing someone else's entire development system if we find out that there is a problem and then have to go be the ones to fix it, right? So I would say that, is probably the way to look at it. That's an opinion. Obviously, the truth is probably much more complicated and varies across many studios. And so there is no pat answer that really can satisfy all of the reasons that people use C++ versus using some other language. But I feel like that's a fairly solid one that is at least somewhat widely applicable, which is just that programmers who care a lot about performance and know that they have to hit 30, 60 frames a second on a diversity of platforms in a lot of scenarios and need that control, just don't feel comfortable based on the track records of these languages embracing them in that way. And that may change in the future, but right now it's still kind of the case pretty much for all the major, for all the AAA game studios that are out there. So Sean McGrath says, no, League of Legends is written in Flash. So I guess there you go. So there's an answer for you. League of Legends is written in Flash, which is totally not that. I've never actually played League of Legends, so I don't know. I just assumed that Riot used C++ because you asked the question that they did, but I don't know anything about Riot themselves. I guess I do know that Blizzard Entertainment wrote World of Warcraft in C++, but I believe, and I could be wrong about this, but I believe that Blizzard Entertainment used C# for Hearthstone, right? Because or something. Didn't they use Unity for Hearthstone or something? And Unity's C#, right? I mean, obviously the underlying stuff is all C++, but some portion of the game, like the game part of Hearthstone written in C#. So, that's an example of a AAA studio, and that's not, one of their sort of AAA titles in the 3D graphics sense or whatever, but it is a major release from them, right? It wasn't a minor release. It was a real thing. So, they were obviously willing to accept C# for at least the game side of the code, assuming that I'm remembering that correctly. That just seems to be my recollection. I don't know anything about League of Legends. If it was really written in Flash, that's hilarious. Because League of Legends, it's funny to think of the fact that Binding of Isaac can't run properly in Flash. And it's just that one thing, whereas League of Legends is this big game and that worked in Flash. That's crazy if that's true. They must be much better at Flash, I guess, than the Binding of Isaac folks were or something. I don't know. That's kind of wild. Oh, all right. Sean, you've been corrected. They say no, League of Legends was written in C++. Only the login client is in Flash. Well, look, I don't know what Riot writes in. I have no friends at Riot even. I guess I have friends at Riot now, but they were not involved in League of Legends. I would be shocked to learn that it was written in Flash. Like, I wouldn't have been shocked to learn it was written in, like, C# or something. But Flash is so slow, like, I would be kind of shocked if it could have been written in Flash. Because Flash is like kind of on the worst end of that spectrum, right? Like C# is a lot more thought through than Flash is. Yes, it has garbage collection, yes, whatever. And, is it something I would rely on? No. But there's a real big difference between relying on Flash and relying on C#. But yeah, so I would be shocked to learn that League of Legends was actually written in Flash. I would be pretty surprised. So yeah. Also, there is a new version of Binding of Isaac that is not in Flash. Well, yeah, but it's Binding of Isaac Rebirth, right? You can't actually get a version of the original Binding of Isaac that's not in Flash, which I wish you could, because I really liked the original, and I wasn't much for the new one. So I wish that I could get the original in non-Flash. But I guess what I'll just do is I'll wait 10 years till computers are so fast that it can actually run a 2D game. A 2D game at frame rate. And then I'll be able to run the original, I guess. SSMC McGrath. SSS McGrath. Air is Flash, though. Air and Flash are basically the same, right? Like, Air is just the packaging, the packaging for Flash. Because Binding of Isaac was written in Air as well, in that sense. Like, you can, when you get the standalone, it comes in Air form. But that's not, there's really no difference between those two things that I know about. Gasto5, what's the difference between arbitrary and random? I guess I'm not sure what context you mean in. Random and arbitrary can mean very different things in certain contexts, I suppose, but I'm not sure what the context is that you're asking. Those are obviously just adjectives, and what they apply to makes a big difference. And Sean, yes, I think that Air has the same runtime. I believe that it's the same runtime as just the normal Flash interpreter that you would install if you download it from Adobe. As far as I know, they don't maintain two separate runtimes, but I could be wrong about that. Gasto5, in the mathematical sense. Well, so in the mathematical sense, something that is random it actually has a bunch of properties, like, non-predictability and even distributions or these sorts of things. something that's arbitrary just means that you didn't care. Like there was no reason for it, right? So I don't know. I guess you'd have to ask pseudonym 73 if there's a mathematical definition of arbitrary. There might be a rigorous mathematical definition for arbitrary, but I don't know that I've ever seen arbitrary used in a precise way. What would you rather write a game in, Java or C#? If for some reason my situation was that I could only write a game in Java or C#, like that was what I had to do, I would quit the game industry. That would be the end of it. Like, I have no interest in programming in either of those languages ever for any reason. So if that's what I had to do, I'd just quit and go do something. I'd do something else with my life before I would write in one of those languages. They hold absolutely no interest. Have you ever smoked weed and programmed? I have never smoked weed, actually, full stop. No. It is legal here in Washington State. So I guess that would be a pretty easy thing to do, but I have never done it. Sorry. Jonathan Blow says that the axiom of choice is kind of about arbitrariness and is kind of controversial. So there you go. Hey, so John, if you're on the stream, can we do a reverse question? Because all the way at the beginning of the stream, somebody asked me if I had designed the game beforehand, because designing it on stream seems like it would be a bad idea, basically, because it would be too much trial and error, right? Or designing on the fly, basically. And what I said was, I designed the game ahead of time, but just because I'm not a game designer, so I don't want the stream to be about game design, because I don't really have much to say in that regard. So that's why I designed it ahead of time, but my feeling from listening to you, as well as other designers that I respect, is that actually designing on the fly is a very important skill. Like I felt like the question was operating on a mistaken premise. And I wanted somebody who really knew game design to weigh in on that, because I don't feel like I'm qualified to answer. But that was, my feeling was just that I felt like it was necessary to correct the assumption that that sort of emergent design where you're playing around with the design is somehow not good, because it felt to me like what I had heard from you and others was that actually that is a very important skill, and you definitely need to develop it and be able to do that if you're a good designer. So I just throw that question out there if you happen to be interested in typing in the answer. It's kind of a yes or no question to some degree, I guess. Okay, so let's go through the last couple of questions here. Oh wait, John answered. So he says, I think designing on the fly is very important, yes. If you know everything you are going to do before you start, you probably aren't doing something very interesting, I think. So yeah, that is what I assumed was the answer from having heard you and other people describe things, but you know, I just didn't really know myself, because I'm not, I don't really have those skills. So I hope the person who asked the question is still listening. There you have a very definitive answer. So design on the fly is actually something you do, I think, want to learn to do. If you're going to be someone, I know certainly personally, if I was going to hire a game designer, I would want to see that skill. Like, I feel like it's really important, but you know, not having done game design much myself, I feel like I should defer to experts on that. And John also says, for me and a lot of people whose games I like, the ideas behind the game are just enough to get you into a territory of interestingness, but then you have to explore that territory, which you can't have done before you go there. Which to me sounds like a very excellent way of putting it, right? I mean, in some sense, it's like saying, you know, I want to go explore this forest or whatever. Well, you don't know exactly all the things that you're going to find there. You just have a feeling that it's going to be interesting because you saw it and it looked kind of cool from the outside, right? So I don't know. It seems to make good intuitive sense. I don't know. Let's see. Why do you say OO is awful? Well, I think we've covered this quite a bit. I don't know that there's a really succinct way to say why, but the general root of it is that programming is about telling a CPU what to do. And there is no concept of object orientation inside a CPU. Like, it's not a thing. And so fundamentally, what writing code is about is actually about figuring out what the process is, like what is the CPU going to do, right? What's it actually going to do? And then from when you figure out what the CPU has to do, from there, the objects are actually kind of obvious, right? So the order of programming is figure out what the CPU is supposed to do, figure out what the data needs to look like to support that, and that, in turn, is your definition of your objects, right? And usually I don't even bother with the object part of it because I think objects are so unimportant that I just think of them as bags of data, right? So that's why we use structs on Handmade Hero, because it's just like, the whole notion of an object in general, I think, is overblown. And so that process is the opposite of how object-oriented encourages you to think. Object-oriented encourages you to think, it's in the word, object-oriented. It encourages you to think from the other direction. So from the objects down to the CPU. And that is very counterproductive because it has nothing to do with what the program actually needs to do. And you don't have to take my word for it. Most people can actually sense this by intuition. Most people, if you ask them to write code to do a particular thing, and you don't tell them about objects or object-oriented or anything of that sort, you just sort of teach them basic stuff how CPU works, they will actually write relatively good code after a while. They'll be like, oh, here's the things I need to do, and I did them in order. Invariably, whenever I see people who do object-oriented programming, it's massively overcomplicated. And there's all of this additional business in there that doesn't actually help the CPU actually do things. And tends to get in the way. And in the worst case, it's like slows things down or makes things more brittle or make things harder to work with in the code. And so what I usually like to say is just the problem with object-oriented programming is not the objects, it's the oriented. It's the fact that you're orienting around the objects. I don't care if the code has objects in it or not. It's the orientation around the objects that's the problem with object-oriented programming. And that focus on thinking that things have to become objects, that they have to be encapsulated, that is the goal, is all unnecessary baggage that gets in the way of good programming. And so that's the reason that I don't like object-oriented. And it's also, unfortunately, something that's kind of sometimes hard to explain because people seem to think that that like certain single things that might show up in object-oriented programming sometimes means you're doing object-oriented programming. Like I actually had someone say to me specifically, I'll give you an example, the fact that I have functions where I take a thing as a first parameter as the pointer is object-oriented programming. So they would consider, like, you know, output playing sounds to be object-oriented because it has audio state as the first parameter, and it's a function that kind of like logically lives with the audio state, right? If that's where your brain is, I don't know what to say. Usually those people just get a mute on Twitter, so I never have to hear from them again, because I don't even know how, I don't know where you go with that, right? And if the person's super nice about it, fine, but it never is, right? The people who make those comments are usually like to make it in a very snide and annoying way, which, you know, is fine if you're trying to go argue with somebody who actually cares about arguing with you, but as far as I'm concerned, people who program object-oriented programming who are really dedicated to that method and want to argue about it, I just assume they let them. right? Like it's less competition for me, right? I would rather, at some level, other programmers program poorly as job security at some level. I'm not going to argue with them about it. Yeah, but maybe that's a mistake because it means, maybe that's why all the stuff that I try to use on a daily basis is all broken. I don't know. So who knows? So that's, object-oriented programming in a nutshell for me. It's the oriented part that I don't like. But I'm not some kind of weird fanatic. I do like other kinds of programming, like the functional programming. I think is very good. I try to do things in a functional form oftentimes, even in C, which is not a functional language, but obviously it supports the ability to write things that are functional because you can just not have side effects, right? So I do like, I think there are a lot of sane programming methodologies. I'm not a zealot who thinks there's only one right way to write a program. What I am zealous about is that object-oriented is not a right way. So I'm more of a anti-OOP. I'm not necessarily pro some other thing as exclusive. I think there's a number of good attack skills for how you program. Data-oriented programming, very interesting. Functional styles, very interesting. These are all techniques that can work together or whatever. I think of things in terms of compression. I've said many times, compression-oriented programming. I think those are all great things, and I hope people learn to do them. It's really just object-oriented just happens to be really bad. And I've never found anything useful or good about it. And so I'm kind of zealously against it because I find that so many people think it's a good idea and have absolutely no actual evidence of that. I've never actually been able to see someone show me, here is the place where this was a really good way to think about this problem. And so it's all right. But I'm not a zealot for some other particular thing. I think there's a lot of good techniques out there programming-wise. And actually, I think good programmers tend to have more than one attack skill, right? They tend to have a lot of different ways that they think about programming, and they pick which ones they want to use based on the circumstances and how things are going, I think. Will Handmade Hero support physics simulation and rendering in different threads? So it already does, actually. Rendering ground chunks happens on a separate thread while the simulation is occurring right now. So that already happens. B3Zman41, you make it sound like those languages have no purpose. They're great for other things than game dev. I disagree. I don't like them for anything, not just game development. So, if you like them, that's great. You should use whatever language you want to use. But I am not going to use them. Shootim73 says, arbitrary is the bottom element of a mathematical lattice. See Azul Systems blog, Cliff 2012-02-12, too much theory for details. So hopefully whoever was asking that question did actually look up that for details. What do you do in order to help prevent carpal tunnel syndrome? Does it get real bad? Anything in particular you try and avoid? I don't really know anything about carpal tunnel syndrome. I've never had carpal tunnel syndrome. If I don't wear my wrist braces, I get tendonitis in right here typically. And for whatever reason, wearing wrist braces, I don't. But I've never really had carpal tunnel syndrome, which I think is where you start to lose some feeling here. Oh, the other thing I have is if I don't keep my wrists and arm, also elbow, and shoulders, I find I do get a little nerve impingement up here or stuff, and I start to lose some feeling in my fingers. But carpal tunnel is about nerve restriction in here, and I've never really had that. My understanding is that is not as common in men. It's much more common in women because they have narrower, I guess, passage for the nerves in here. Whereas men have a wider one. And so my understanding was actually a lot of times like people think they have carpal tunnel syndrome maybe, but they haven't actually determined that that's actually what they have. So a lot of times if a guy thinks they have carpal tunnel syndrome, I would say make sure that's actually what you have if you think you might have that, because you may have something else, right? And then trying to fix carpal tunnel syndrome isn't going to help you because that's not what you have, right? So you want to make sure you actually know if you're having hand issues, you want to make sure that you know whether you have like tendonitis or a nerve impingement somewhere or carpal tunnel or whatever first before you try to do it, which can be tough to diagnose, but you can try things, try experiments, keeping various areas warm, aligning, changing the alignment of how you're doing things, wearing braces on different parts, try to figure out what does and does not affect it is definitely worth doing before you try to cure something that you don't maybe necessarily have, while something that you do have is going unchecked, which can be a problem. Let's see. I missed part of the stream, so you may have answered this. Do you know of any OpenGL resources that actually explain why they are doing what they are doing? The ARC synthesis tutorials I try to mention because I think those are pretty good. But honestly, no, I really don't. It's underdocumented. It's definitely underdocumented. Guesto5, so by what you said, can I conclude that you have not written a game design document? Well, yes and no. I actually do have a fair bit of game design stuff. I don't, like I said, I'm not a formal game designer, so I don't really know very much about writing a game design document. Because you put that in capital letters, like it was a very specific thing. Sounds like the kind of thing a producer wants, where it's like 150 pages and lots of verbosity. Thordura, huh, so OO is kind of like when you design a game ahead. Yeah, I mean, and like I tried to impress, hopefully, in fact, this stream, we've mentioned it many times now. My understanding from really good game designers is that you don't want to design a game up front like that. Like, that's not how you do it. And the same is true of code. The reason I'm doing that in Handmade Hero is I'm not a game designer. That's not my skill set. And so I tried to put together a design that I'd be like, okay, here's a series of things that we'd have to implement. It'll be interesting, hopefully, but I'm not a game designer. I can't promise you anything about Handmade Hero being some amazing game design, because that's not what I do. Handmade Hero is a programming project. It's about game development, not game design. And so, and I will, when we get to the game part of things, like I said, maybe day 200, 250, somewhere around there. I'm not sure when we'll switch over to doing mostly game work and not really doing any engine stuff anymore. What I will say often, and just to make sure everyone knows, is like, it's still about game programming even at that point, right? I'm showing how to implement a bunch of game design things, and I've picked the game design things to try to make it so that we have to do a lot of the same kinds of code that we would have to do in any intricate, sort of advanced game design. But I'm not trying to show you how to game design. I do not think you would want to make a game design upfront like that if you were actually trying to make a game and it was about making a great design. And so, that's a whole different skill set that you will need to learn from someone else's stream, because I do not know anything about game design and I cannot help you there. I can only show you how to make a game from a design that someone else does, and hopefully that will be enough for anyone to work with who has design skills. And if you don't have design skills, there's nothing I can say other than beg John to do a tutorial, or beg someone else who's a great game designer to do a tutorial or something, because there's nothing I can do to help you there. There's nothing I can do. Is this project planned to be a game playable for real, in quotes, or more like, quote, how I create games? I'm not sure what you mean, but this game will be, should be totally professional programming throughout. Meaning, when you actually play it, it will feel expertly tuned. The code will run extremely smoothly, no loading screens, no craziness, everything's streamed, everything's super responsive. Like, it should be absolutely top-notch code-wise. And Yangshin's also doing some pretty fantastic art for it, so I think it will also look very good. The only thing, like I said, is not a game designer, and the design is specifically selected to force us to do a bunch of programming things. So game design-wise, it will be relatively traditional. Don't expect anything crazy, groundbreaking, or whatever in the design, because that is off limits for this project. Since we are talking about programming languages, I must ask, how do you feel about Perl? I haven't used much Perl. I think I wrote like 1 or 2 Perl scripts, but I didn't think it was particularly noteworthy, but I didn't spend enough time with it to form a educated opinion. Do you feel Minecraft was a success because of the idea rather than the execution for the first time ever? Well, I don't know that you could say that Minecraft was the first time that something was successful because of an idea rather than the execution. I think there probably have been games in the past that were successful because of their idea rather than their execution. But yeah, probably. I mean, you know, there's a lot of things about Minecraft that could have been executed better than they were. But like anything else, if you have a unique enough thing that you make, and it happens to hit that sweet spot of something that people really want to play, then you can get a lot of slack in the execution, right? And so, you know, that's great if you can do it. Personally, I haven't played Minecraft. I don't really know much about it. So I don't really have an opinion about why it was successful or anything. I just know that obviously if you look at screenshots of Minecraft, obviously you could have imagined a much more polished version of that game. But you know, whether that's how relevant that is, I don't know. You could also imagine a less polished version of it, right? So they did polish it to a certain degree. So I don't know. All right, I think we've come to the end. We've come to the end of the questions. Someone asked, dynamically generated maps. Yes, the maps will be dynamically generated. They are in fact already dynamically generated. We just don't have any actual code to generate interesting dynamic maps, but it actually does generate the map at the beginning. It's just stand-in, so it's a really boring map. All right. All right, everyone, I'm going to wind it down. I'm going to wind it down. So let's go ahead and close this guy and switch over here. All right, everyone, thank you for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always do so. If you pre-order the game on handmadehero.org, you can get the source code, which I upload every night after I am done. So if you'd like to play around with it and experiment, do whatever you want to do there as part of learning to program, you can do so. And also, we have a forum site if you want to ask questions there. We also have a Patreon page you can go to if you would like to support the video series that we do here. And we also have a tweet bot that tells you when the video series is live on Twitch, so you can plan to be here if it's something that you want to catch live. That's the place to do it. I will be back here again tomorrow, 5 p.m. Pacific Daylight Time. I think the mixer is basically done. I would like to move volume out to explicit since it seemed like that was a useful thing to do. And maybe we should support stereo sounds, which would just be calling that loop twice in the case where we have stereo. So I don't know. You know, I think maybe one more day would be a good idea, and we'll take a look. So let's go ahead and plan on doing one more day audio tomorrow, and then probably move on to the asset pack file stuff, which I think should be pretty straightforward because we've pretty much already done the vast majority of the work that we need to do for it. So it's going to be a bit like shooting fish in a barrel. Now, why fish would be in a barrel and why you would feel the need to shoot them at that point, I don't know. But that's just what the saying is. So until tomorrow, everyone, have a good one. And I will catch you guys on the internet. Take it easy.